All right, welcome to part 2 of the CFR3 guided notes. As you can tell, I have done that example that you're supposed to do from part 1. You've got the parent function is the quadratic or x squared there. And also we had vertical stretch because the number multiplying out front is bigger than 1. We had left 3 because it's x plus 3 or x minus negative 3. And we had at the end this plus 2 hanging out way out there. That gives us an up 2. All right, with that said, let's go ahead and move on. Let's finish up the stretches and compressions. We just did the vertical and the vertical compression and stretches, right? If it was multiplying outside by a bigger number, it stretched it. If it was multiplying outside by a number between 0 and 1, it compressed it. Now we're going to do the horizontal stretch and compression. Now, just like we did before, we're going to start with this new function. We've got this brand new function we're going to start with. We're going to call it, I'm going to get really creative here. I'm thinking of a letter I'm going to use, and I'm going to call it g of x. It's my new function. And how I describe that, just like we had before, how that horizontal translation was inside the function, the horizontal stretch and compression also happens inside the function. On top of that, it also makes sense that it's going to be multiplying inside the function because we're doing a stretch or compression. So this looks like f of something times x, and that something times x is b. I'm going to call it b because why not? Again, the purple part there, the f of x is my parent function. Oh, let's go ahead and use the right color there. This f of x part is my parent function. And this b value, this is my stretch or compression. This is my stretch or compression value. And I mean, let's go ahead and do this. Well, when it was multiplying out front, when a was greater than 1, it was a vertical stretch. So it only makes sense that when b is greater than 1, multiplying on the inside, this is a horizontal compression. Told you it was going to be opposite. Horizontal compression. Horizontal compression. Okay. Why is that? Well, let's take a look. Let's do that thing where we, graph our base parent function, f of x equals x squared, 0, 0, 1, 1, 2, 4, and I'll throw in 3, 9, and also the negatives here, negative 1, 1, negative 2, 4, and negative 3, 9. Okay, got those going on in here. Fantastic. Now let's do this where we compress it on the inside. What does that even look like? Well, here's what this is going to look like. This horizontal compression, think about it this way. I am going to take in, hold on, so you can squeeze it. If I'm squeezing it from a horizontal compression way, it's going to make it taller. It's going to get skinnier, right? It's going to get narrower. Let's just try that again. It's going to get narrower because I'm squeezing it. I'm compressing it in the horizontal sense. Let's do this guy right here. We're going to call this one, what letter? How about d of x equals 2x squared. Not 2 times x squared, but it's 2 times x and then square it. Well, let's do that here. 0, if I plug in 0, 0 times 2 is 0, and 0 times 0, 0 squared is also 0. Okay, we got that one going. Let's try 1. Let's try 1. If I plug 1 in, 1 times 2, or 2 times 1 is 2. 2 squared is 4. So 1 is 4. Oh, that's interesting, which would make negative 1. Negative 1 times 2 is negative 2, and negative 2 squared is 4. That's really interesting. Let's try 2. So 2 times 2 is 4, and 4 squared is 16. And holy cow, this got out of control fast. Let's try that again. So did that. Yeah. This made it narrower. It compressed it in a horizontal sense. That's how that works. I use some weird colors now. I appreciate that, or I apologize for that one. Let's look at, go this green. What if this value, again, between 0 and 1, I'm going to tell you what happens with negative numbers here pretty quick, okay? What if this b value is somehow between 0 and 1? And also it can't be 0, because if I'm multiplying by 0, guess what happens? The function kind of goes away. And if I'm multiplying by 1, we just have the base function. That's why it's just 0 is less than b, which is less than 1. It's not or equal to in this case. So if I do that, this is going to be my horizontal stretch. Horizontal stretch. And if I'm stretching it out, if I'm taking something and I'm going to pull it apart, it's going to be wider, especially with this one, this x squared business. It's going to be wider. The horizontal stretch will make it wider. And let me prove that to you. I'm going to do what's a good one I haven't used? I of x. They're all good ones. I of x. And we're going to do half x and then square that. We can do half x and then square that. Well, let's start with our graphing here. 0, 0, because 0 times half is 0 times, and then 0 squared is 0. Okay. Let's do, you know what? I'm going to skip some of the fraction ones because I know how much you guys love fractions. What if I went 2? If x was 2, 2 times half is 1, and then 1 squared is 1. So at 2, I would have 1. The same would be true for negative 2. Let's do 3. Let's do 4 because we can, get non-fraction numbers. 4. So when x is 4, 4 times half is 2, and then 2 squared is 2. So I've got 4, and I'd have the same thing at the negative. So look at this guy. I said it was going to be wider. Was I right? Yeah. Yes, I was. It is wider. So that value in there would make a horizontal stretch. It pulls, it's stretching it out. It's not compressing, it's stretching. Okay, whew, that's a lot. That's a lot. That takes care of 4 of the possible 6 transformations you could have for any function. Let's look down here. I'm going to do this business here. I'm going to say that the parent function here is x cubed, which is my cubic. And that's because I see this cube up here. Okay. Okay, let's look for the things we already know. Let's look to see, is there a vertical translation? Is there a number adding or subtracting way out at the far right side at the end? Yep, there sure is. This is going to go down 1 for sure. We got down 1 in here. Do I have something adding or subtracting? I'm going inside the function. These are the parentheses that determine where the inside of the function is. Inside of the function, I've got 3 times x minus 3. Let's focus on this x minus 3. Don't distribute through. You don't have to do anything. There's no like distributing calculations here. X minus 3. Well, that's the weird one. Even though it's x minus 3, we know that goes right 3. Right 3. Ooh, right 3. Okay, so we've taken care of the x minus 3 and this minus 1. I have got something multiplying inside the function. That's my b value. This b value is greater than 1. This is a horizontal compression. That's just like this up here. That is a horizontal compression. That 3 right here, horizontal compression. horizontal compression. Yes, I am kind of shorthanding this one a little bit. And I've still also got this 2 multiplying out here. That's what we learned just a second ago. We called that a vertical, not a compression in this case, because it's what we think it would be. This is a vertical stretch. Vertical stretch. Those are the 4 different things that we have in this one. Now, I'm going to leave you to this one on your own, this next one. And it's going to be in when I post this on Google Classroom, that'll be in there. The solutions will be in there to that G of X one, but you're going to have to wait and look at it. Let's move on to the last part here. I'm going to skip the last page, by the way, which is even and odd functions. I'm going to skip that for the time being. We will come back to it eventually, but I'm going to skip it for the time being. We need to talk about reflections. We need to talk about reflections. Let's go back for just a second. Let's go back to that whole vertical stretch and compression business. Let's go to that vertical stretch and compression business. If I had G of X is equal to, and I had A times whatever my parent function was, f of X. We called that blue part right in here. Again, this is new function. This is our new. This is our parent function. This is our vertical stretch or vertical compression. Vertical stretch or vertical compression, depending on what that number is, okay? Here's the other part to that, because I said, well, I didn't take care of what happens when it's a negative number. If it's a negative number, if the absolute value, I'm sorry, if A, I'm getting ahead of myself, if A is negative, if A is negative, the function reflects over an axis. And since I'm talking about vertical stretches, we're going to do a vertical reflection. What axis do you think that's going to reflect over? And I know you've done the pre-work. So you saw that it's going to reflect over the x-axis. If A is negative, there is a reflection over the x-axis. The function reflects over the x-axis. The function reflects over the x-axis. I'm going to use a different parent function this time. I'm going to use instead the square root of x. The square root of x. And that looks like this: 0, 0, 1, 1, 4, 2, and 9, 3. Looks like this guy right here. It's going to be a little easier to see some of these things. What I'm going to say is, what if I had, let's go different color. It's very colorful. I'm going to go with n of x, because why not, is negative square root of x. This is like -1 times the square root of x. Okay, it's a negative square root of x. I am saying that that is going to reflect over the x-axis because of that negative. And you've already done that. You've already done that in the pre-work. We saw that when you put that negative out front, it reflected over the x-axis. 0, 0 stays because it's on the x-axis. 4, 2 becomes 4, -2 because the square root of 4 is 2 times -1 is -2. Same would be true for 9 to -3. So this is my n of x. This is my one reflection right here, not one direction. Not one direction, one reflection. Make sure we have these labeled correctly, okay? And now you're saying, okay, so if I just did the vertical stretch and compression stuff again, I'm probably going to come back to the horizontal stretch and reflection, right? That's the most logical thing. And you would be, yeah, you're right. No, that's exactly what we're going to do here. It's exactly what we're going to do here. We're going to come back to this g of x equals purple. And that value, we're going to roll with blue. Why not? B times x. Okay. That B value, again, this B value is our horizontal stretch or horizontal compression, depending if that value is bigger than 1 or less than 1. I'm sorry, bigger than 1 or between 0 and 1. And what we're going to say is if B is negative, we're doing horizontal this time. So horizontal is left and right. This is going to reflect over which axis? If B is negative, the function reflects over the y-axis. The function reflects over the y-axis. What does that look like? I'm glad you asked. That's a great question. We're going to call this guy, I think will this yellow show up? Oh yeah, not a chance, not a chance. Let's try a different one. We'll go this one. Why not? We'll call this one h of x. And this h of x, we're going to say is the square root of negative x. Since that's in there, this is a reflect over the y-axis. And if you don't believe me, plot it again. That was in the pre-work. If you don't believe me, plot it again. And I will tell you that if you do that, if I take this parent function of f of x, this square root function, I would end up with 0, 0. If I put in, well, if I put in 1, this is the interesting part, right? If I put 1 in down here, what's the square root of negative 1? You can't do that yet. Wait a little bit. You'll see that soon. It's not a real number, it's an imaginary number. And yes, imaginary numbers are a thing. So you'd have to plug in negative numbers. Negative 1 would be 1. Negative 4 would be 2. And negative 9 would be positive 3. You'd have a reflection over the y-axis. This is my h of x. Lots of things. So, Mr. Brayman, what happens? What happens if you put negatives in both places? I'm glad you asked. What if you had something like x of x? No, I'm not going to do that one. Z of x. Negative square root of negative x. Great question. Well, this would reflect over the x-axis. And this one on the inside, this negative, would reflect over the y-axis. I would end up with something that looks like this. What do I call that? Z of x? Okay. That's a lot. I know that's a lot. That's why I broke it up into 2. We're going to practice this. And as long as you're practicing and working towards it, it's going to make sense. Graph the things if you don't understand. Graph the things if you don't understand. Graph the functions. Identify the parent function. We've been working with this one a lot. This is square root of x. On this one, square root of x. Square root. And I told you there's at most 6. This one does not have 6. This has 5. This has up 6. This has right 3. This has, ooh, that's a B multiplying on there. Not a horizontal stretch. This is a horizontal compression. Horizontal compression. We have this value out here. That A value is a -2, but it's since we're going to try to treat the negative a little bit different, right? If it's negative, if it's just that 2 value is what we're looking for, since it's 2 bigger than 1, we're going to have a vertical stretch. And since we do have this negative out front, that is a reflection. And since it's a vertical reflection, it's a reflection over the x-axis. Reflection over the x-axis. That one had 5. The next one has 6. You're gonna have to check the solutions. Which I highly suggest you do. Okay, that's a lot. Ask questions, try. Watch these videos first, then we'll knock stuff out. Take care, have a great day.